Hello and welcome back. We will be moving on to section 3.1, which is all about radians. And to introduce radians, I want to look at this circle here. In the circle, I have the origin as the center point. So we will have a radius of r. And what I want to do is I want to talk about arc length. So if we go around the circle, let's say that we pick some angle, call it theta. We can look at the length of the circle between those 2 points. So if I trace this out, we can talk about the length of that line. It'll be curved, so it'll be a little bit longer than if we traveled sort of as the crow flies in a straight line, and we'll call that length S. And we could do this with for any angle. We could go almost all the way around, but there is a very special angle where the following will happen. We know that the distance from the center to the outside of the circle is always going to be r, and there is a very special angle where the length that we travel around the circle is also going to be r. So let's imagine that we're in this situation, that r here, whatever the radius is in fact equal to this arc length. That's only going to happen one place in the circle. If I drew an angle that was a lot bigger, let's say maybe over here, the arc length from there all the way around to here, if I traced around the circle, that would be a lot longer. So it turns out that there is only one angle for which the radius is going to be equal to the distance that we travel along the outside. That angle is called 1 radian. So we'll give this angle essentially a name, and we'll say that it is 1 radian in length. For instance, if I wanted to go 2 radians, where would that be? Well, if we draw another circle. This is a very bad circle, but oh well. So if I wanted to go 2 radians around, I would have to so starting here at the x-axis, I would travel around until I've gone a distance of 2 times r. So again, r is the distance from the origin to the outside of the circle, and what I would do is I would be traveling along the outside of the circle until this length here, so the length is equal to 2 times r, and wherever I end up, it'll be about there, I suppose. This angle is going to be 2 radians wide. So we can talk about 1 radian wide angle, a 2 radian wide angle, 3 radians, 4 radians. We can so this is sort of an alternative to degrees. Again, we can talk about an angle that's so many degrees wide, or we can talk about an angle that's so many radians wide. So how do we define radians in general? I know where 1 radian is. It's about right there, where the arc length and the radius are the same. Generally, the radian measure of an angle is going to be the arc length divided by r. So when the arc length and r are exactly the same, if you take r divided by r, you just get 1, which is why we get 1 when the arc length and the radius are the same. But in general, we'll just take the entire arc length of that angle and divide it by r. So for instance, the circumference of a circle is 2 times pi times r. So if I were to go all the way around the outside of a circle, all the way, how long of a line did I just draw? So the length of the outside of a circle is going to be 2 times pi times r. So if I look at the angle that's formed here, that angle, I know that that this angle is 360 degrees if I go all the way around, if I do 1 full rotation. But I also know that I can also find the radian measure, which is going to be the entire arc length, which is 2 pi r, and I'm going to divide it by the radius r to get 2 pi. And one thing I want to point out, and this is going to sound strange, but this is just the way that the math works out. 2 pi r, what are the units here? Well, 2 doesn't have units, pi doesn't have units, r is a length. So its units may be something like feet, or meters, or something else that measures length. The bottom, r, is also going to be a length. The radius of a circle is a length. So it will also have units, and it's got the same units as the radius on top. So whatever those units are, they actually cancel out. So when I say that an angle has measured 2 pi radians, radians isn't actually a unit. All of the feet in this radius, or the meters or centimeters or whatever I'm using, they cancel out. So technically, radians are unitless. This may sound strange, and it won't necessarily have an effect, but it's something interesting to notice. So I want to do one more example where I calculate radians by using the arc length divided by the radius. So for instance, if I have another circle here, now let's say I travel halfway around the circle. Let's say I travel from here, and I come up and around, and I end up on the other side. So the question is, what is the arc length here? What is the length of that? Well, if I go all the way around, the circumference is going to be 2 times pi times r. So if I go halfway around, this arc length is going to be half of this. So it's just going to be pi times r. Well, just like before, I know that this angle, which if I go halfway around a circle, that's 180 degrees. Or I can take the arc length, which is pi over r, and I can divide it by the radius to get exactly pi radians. So we have this, maybe I should have given myself a little bit more space here. So I know that 180 degrees is the same thing as pi radians. And using this, I can convert between degrees and radians fairly easily. So let me show you this process. It's very simple. We have 180 degrees is the same thing as pi radians. So let's look at pi divided by 4 radians. If I take pi divided by 4 radians, normally when I'm doing unit conversion, here is the general strategy. I want my radians to cancel, so I want radians on the bottom of the fraction, and I want whatever units I want on the top, so it's going to be degrees. And then the question is, how many radians, when are radians and degrees equal? Well, 180 degrees is pi radians. And if I do this, so this is pi divided by 4 times 180 degrees over pi, the radians essentially cancel. Pi will essentially cancel, and I'll get 180 degrees divided by 4. And when I do this math, I will get 45 degrees. So pi over 4 radians is the same thing as 45 degrees. If we draw a little picture, let's do this. I know that pi radians is going to be 180 degrees. So this is going to be pi radians. Well, if I cut that in half, pi divided by 2 is going to be right here. And if I cut this in half again, this is going to be pi divided by 4. So we're right in between. Well, I know that pi divided by 2, that's half of 180 degrees, so that's going to be 90 degree angle. Yep, that makes sense. And then half of a 90 degree angle is 45. So everything sort of makes sense. let's do another one. If I have 2/3 pi, so 2 pi over 3 radians, I want to cancel out the radians with degrees, and in order to be multiplying by 1, I can't change this value, so I have to multiply by 1. I need something on the top and bottom of this fraction that are equal. So I know that 180 degrees is the same thing as pi radians. So again, this right here is equal to 1, since 180 degrees is the same thing as pi radians. So the radians will cancel. Pi will cancel. So this is going to be 2/3 of 180, which will be, if I can do this in my head, 120 degrees. 1/3 of 180 would be 60, so 2/3 is 120. So 2 pi over 3 radians is the same thing as 120 degrees. Now 1 radian, this was the special place where the arc length was equal to the radius. So this was about here, maybe there's slightly better, where I have my radius going from the inside of the circle to the outside, and the arc length is the distance around here. So as long as both of those are the same, this angle in here is going to be 1 radian. But the question is, how many degrees is it? Well, I can take 1 radian, and then I can multiply by, again, I want the radians to cancel, so I'll put radians on bottom, and I'll put degrees on top. But in order for this to be a unit, in order for this to be, just exactly equal to 1, I need the same thing on top and bottom. Well, 180 degrees is the same thing as pi radians. And if I multiply 1 by this, well, 180 divided by pi is exactly this angle. And this is not something that I can do in my head. I can't divide by pi very easily. If we whip out our calculator and I take 180 and I divide by pi, my answer is going to be 52.29. So I'll round it to 1 decimal place, so 57.3. This is going to be approximately equal to 57.3 degrees. Not exactly, but pretty close to a 60-degree angle. And that's just going to be the magic angle where the radius is in fact going to be equal to the arc length. In my next video, I will look at converting degrees back to radians. It's exactly the same process, and I'll go through a circle and look at where some common degrees and radians line up.